Hi guys, in this video we are going to see about encoding techniques, how digital data is converted into analog signal. In our last video, we have seen how digital data converted into analog and digital signal. But in some cases, there are situations where we can transfer only analog signals. So there should be a mechanism to convert digital data into analog signals. By the way, I am Tibana Govindaraja, undergraduate at University of Malta. If you have any doubts, don't hesitate to contact me over the LinkedIn. That also Tibana Govindaraja. So, to understand how digital data converted into analog signal, first of all, we should understand the concept of modulation. Modulation, in the sense, it's an encoding information in a way that is suitable for the transmissions, because all the forms cannot be transmitted. To transmit it over guided or unguided media, there should be something specific form. For example, over the telecom communication, only analog signals are allowed. So the data should transfer to the specific form. So the data is mixed with the higher signal, which is different in frequency or amplitude or anything. So mixed with the higher signal to convert it for the analog signal. Why we are doing the modulation? Because modulation helps to strengthen the signal, so it can be transferred for the longer distance. If we do not do the modulation, we can't transfer the signal for the longer distance. So there are two main types of modulation. That is analog modulation and digital modulation. Analog modulation, in the sense, analog data is transferred into the analog signals. That is example, amplitude modulation, frequency modulation, etc. We can see the analog modulation in our later videos. In this video, we are going to see about the digital modulation. Digital modulation, in the sense, how digital data, that means binary zeros and ones, are converted into the analog signals. There are three basic digital encoding modulation techniques. That means there are three ways how we are converting digital data, binary zeros and ones, into the analog signals. First one, amplitude shift keying. Second one, frequency shift keying, called FSK. And third one, phase shift keying. And there are also called QAM, quadrature amplitude modulation. Is the combination of amplitude shift keying and phase shift keying. In the sense, for example, amplitude shift keying, which is also referred as ASK. It means we are denoting the binary zeros and ones, that means digital data, by the separate amplitude. So two binary values are represented by different amplitudes of carrier frequency. For example, in some of the cases, we are representing 0 for the normally if the data binary data were transmitted in this form, this is 1 and this is 0. So this 0 is represented by one of the amplitude, and this 1 is represented by another constant amplitude. So these two binary values will be represented by two different amplitudes. In some of the cases, we are representing the absence of carrier as the one amplitude. So the resulting transmitted signal for 1 bit time will be A cos 2 pi FCT. And this is mainly used in the transmission over optical fibers. If we see the example here, this is the digital data 001101000010. So here we are converting to the analog signal using ASK. So here 0 is represented by this amplitude. Here there is no carrier signal. And here this is represented by A cos 2 pi FCT. So this is how it is represented. In our next video, we can see how frequency shift keying is used in the transmission of digital data into analog signals.